Light and your radio signal from the little box in your living room are the same thing. Identical. They are the same phenomenon, obeying the same laws, born of the same physics. And I can prove that to you in the next few minutes. But if that is true, and it is, then you have a real problem on your hands. Because one of them sails right through the walls of your house as if the walls were not there. And the other one, the light from the lamp in your kitchen, stops dead at the first wall it hits. Cannot get through. Not one bit. Same physics, same laws, different result. Somebody is lying to you, or you have been thinking about walls wrong your entire life. Let me set this up properly so you see why it is disturbing. You turn on a lamp, you see the light. You walk into the next room, you close the door. Gone, no light gets through. The wall stops it cold. You have known this since you were 3 years old. It is one of the most obvious facts about the world. Walls block light. That is practically the definition of a wall. Meanwhile, there is a little radio transmitter somewhere in your house. It sends out a signal. That signal goes through the wall, through the door, through the ceiling if it has to. It reaches a device sitting on your desk in another room, on another floor, behind multiple layers of wood and plaster and paint. No problem at all. You do not think twice about this. But you should, you really should. Because those two things, the light from the lamp and the radio signal from that box, are traveling as electromagnetic waves. The same kind of wave. James Clerk Maxwell figured this out over 100 years ago, and it has never been wrong since. They are both disturbances in the electromagnetic field. They both travel at the speed of light. They both have an electric component and a magnetic component oscillating at right angles to each other. They are the same stuff. So what gives the wall the right to stop one and let the other through? I mean, really think about it. If someone had never seen either phenomenon and you described both to them, they would say you were contradicting yourself. You were telling me there is a kind of wave that travels at 186,000 miles per second, and when this wave hits a half-inch thick piece of drywall, it stops, completely absorbed, not a trace gets through. And then you are telling me there is another kind of wave, the exact same type of physical phenomenon, same speed, same fundamental nature, and it goes through that wall like the wall is made of fog. They would say, pick one, either walls stop electromagnetic waves or they do not. You cannot have it both ways. But nature does have it both ways. And the reason is, one of the most beautiful things in all of physics, most people when they first hear this question come up with an answer pretty quickly. They say, well, the radio wave has a much longer wavelength, so it sort of goes around the wall, or it fits through gaps, or it is too big for the wall to notice. And the light wave is tiny, so it hits the atoms and gets stuck. That sounds reasonable. It sounds like it might be right. In fact, I have heard physics students say this with great confidence. And I want you to hold on to that idea for a few minutes, because it is the idea we are going to take apart. Here is the picture most people have in their heads. They imagine the wall is like a chain link fence. The radio wave is like a big beach ball. You try to push a beach ball through a chain link fence, it does not fit, it just smushes against it and bounces off. But wait, the radio wave gets through, so maybe the radio wave is more like a big ocean swell, and the chain link fence is too small to interfere with it. The wave just rolls right over. Meanwhile, the light wave is like a marble, and the marble hits the chain links and stops. That is the mental picture, and I am telling you it is completely wrong. Not a little wrong, not mostly right, with a small correction needed. It is fundamentally wrong. It is thinking about the problem with the wrong machinery entirely. And once I show you why, you will understand something very deep about how light and matter actually talk to each other. Let me start by destroying the idea with a simple observation. If the chain link fence theory were right, if it were just about size, about the wavelength fitting through the gaps between atoms, then you would predict a very specific thing. You would predict that anything with a wavelength bigger than the spaces between atoms in a wall should pass right through, and anything with a wavelength smaller than those spaces should be blocked. Fine, let us check that against reality. The atoms in a typical wall, say drywall or brick or wood, they are separated by distances on the order of a few angstroms. An angstrom is 1/10,000,000th of a meter, very, very small. The wavelength of visible light is a few hundred nanometers. That is a few thousand angstroms. The wavelength of light is already much, much bigger than the gaps between atoms. By the chain link fence theory, light should sail right through. It is thousands of times larger than the spaces between atoms. If you are a wave, and the obstacles are thousands of times smaller than you, the fence model says you should not even notice them. But light does not get through the wall, so the size argument has a problem right from the start. It gets worse. X-rays have wavelengths that are much shorter than visible light, about the same size as the distance between atoms. In fact, 1 angstrom, give or take. According to the size model, X-rays should have a terrible time getting through walls. They are the same size as the gaps. They should be like a marble hitting a chain-link fence stopped cold. But what actually happens? X-rays go right through you, through your skin, through your muscle. They only slow down when they hit dense stuff like bone or lead. X-rays are shorter than light, and they get through more easily. That is the exact opposite of what the simple size theory predicts. So we have a situation where long radio waves get through walls. Very short X-rays also get through walls, but visible light, which sits right in the middle, gets stopped. Think about that. The stuff in the middle is blocked. The stuff on either side gets through. That is not a size story. Something else entirely is happening. And if you need one more nail in the coffin of the size theory, consider this. Take 2 walls. One is made of wood, one is made of glass. Same thickness, roughly similar atomic spacing, very similar density even. Light goes through the glass and stops at the wood. If it were about size, about wavelength versus gap, those 2 walls should behave identically. They are both solids, both full of atoms, packed tightly together, but one is transparent and one is opaque. The size theory cannot explain that. Not even close. Or consider water. Water is a liquid. Its molecules are constantly moving, sliding past each other. If anything, the gaps between molecules in water are larger and more variable than in a solid wall. And yet light goes right through water. You can see the bottom of a clear lake. You can see your hand through a glass of water. The molecules are loose, the spacing is generous, and light sails right through. Meanwhile, that solid wall with its atoms locked rigidly in place blocks every photon. The geometry is almost the opposite of what you would expect from the size argument. The tightly packed solid should be harder to get through if it were about physical gaps. But it is the tightly packed solid wall that blocks light, while the loosely arranged liquid lets it through. There is no saving the chain-link fence theory. It is dead. We need something better. Let me tell you what is actually going on. And this is the beautiful part. The wall is not a passive barrier. The wall is not just sitting there like a fence. The wall is an active participant in this interaction. The wall is made of atoms, and those atoms have electrons, and those electrons are the whole story. Everything depends on what those electrons can and cannot do when a wave hits them. An electron in an atom is not free to do whatever it wants. It is bound. It sits in what we call an energy level. You can think of it roughly like a ball sitting on a specific step of a staircase. The ball can be on the first step or the second step or the 5th step, but it cannot hover between steps. The steps have definite heights, definite energy differences between them. To move an electron from one step to a higher step, you have to give it exactly the right amount of energy. Not roughly the right amount, exactly the right amount. Now, here is the key. A photon of light carries energy, and the amount of energy it carries is directly tied to its frequency. Higher frequency means higher energy. Lower frequency means lower energy. This is one of the great discoveries of 20th century physics. Max Planck proposed it. Einstein made it concrete with the photoelectric effect, and it has been confirmed in every experiment since. The energy of a photon equals Planck's constant times the frequency. E equals h times f. That is the rule. So when an electromagnetic wave hits a wall, it is sending photons at the atoms in the wall. Each photon carries a specific amount of energy determined by the frequency of the wave. The question then becomes, does that particular amount of energy match any of the jumps available to the electrons in the wall's atoms? If the energy matches, if the photon's energy corresponds to the gap between one electron energy level and another, the electron can absorb the photon. It jumps up to the higher level. The photon is gone. Its energy has been swallowed by the atom. The light does not get through. If the energy does not match any available jump, the electron cannot absorb the photon. It has no way to accept that energy. The photon passes through. The material is transparent to that frequency. That is the whole story. That is everything. The wall is not blocking light because light is the wrong size. The wall is blocking light because By a coincidence of atomic structure, the electrons in drywall and wood and brick happen to have energy level gaps that match the energy of visible light photons. Let me give you an analogy that I think captures this perfectly. Imagine you are at a music hall, and on stage there are 100 tuning forks, all tuned to different notes. You walk in and you sing a note. If your note matches one of those tuning forks, that fork starts ringing. It absorbs the energy of your voice. The sound does not make it past the stage. The fork catches it. But if you sing a note that none of the forks are tuned to, nothing resonates. Your voice passes right through the hall, reflects off the back wall, comes right back. The hall might as well have been empty. The wall full of atoms is the stage full of tuning forks. The photon is the singer, and whether the song gets through depends entirely on whether any fork in the hall is tuned to that note. Visible light photons are singing the exact note that the electron tuning forks in drywall are tuned to. Radio photons are singing so low that none of the forks respond. It is a resonance phenomenon, not a size phenomenon. And let me say that again because it is important. It is a coincidence. There is nothing fundamental about walls blocking light. If the atoms in your walls were different, if they had different energy level spacings, light would go right through. And in fact, you know a material like that. It is called glass. Glass is made of atoms. It is solid. It is a wall, if you want it to be. But light passes through glass beautifully. Why? Because the electrons in the silicon dioxide molecules that make up glass do not have energy level gaps that match visible light photons. The photons arrive, and the electrons have nowhere to put that energy, so the photons pass right through. Glass is transparent to light, not because it has holes in it, not because it is thin, not because of any geometric property at all. It is transparent because its electrons cannot eat visible light photons. They are on the wrong steps of the staircase. But now I want to hit you with the next surprise. Glass blocks ultraviolet light. You cannot get a sunburn through a window. Most of the ultraviolet coming from the sun gets stopped by the glass. Why? Because ultraviolet photons have higher energy than visible light photons, and that higher energy does match some of the energy level gaps in glass. The electrons in glass can absorb ultraviolet. They can eat those photons. So ultraviolet gets blocked, and visible light sails through. Same material, different frequencies, different outcomes. This is not a size story. This is an energy matching story. Think about what this means for a moment. A window is a wall for ants doing their ultraviolet dances, and a clear opening for you and me. A moth that sees an ultraviolet looks at a window and sees something opaque, like you look at a brick wall. Same window, different experience. Who is right? Both of them. Neither of them. The window does not have an intrinsic property of being transparent or opaque. It depends on who is looking and what frequency they are looking with. Now here is something that might puzzle you. If the story is all about electron energy levels, and the electron energy levels are determined by what atoms the material is made of, then how come glass and sand look so different? They are both made of silicon and oxygen. Sand is opaque and gritty. Glass is perfectly transparent. Same atoms. How can the same atoms produce different electron energy levels? The answer is structure. In sand, you have tiny crystals of silicon dioxide, each one a miniature ordered arrangement of atoms. But the grains are small, they have rough surfaces, and they scatter light in every direction. The photons bounce around between the grain surfaces and never make it through. In glass, those same silicon and oxygen atoms are arranged in a smooth, amorphous, non-crystalline structure. No grain boundaries, no rough surfaces. The electrons have the same energy levels, but the photons can travel through without being scattered off of tiny crystal faces. So it is not just about absorption. Scattering matters too, and scattering depends on the physical structure of the material at the scale of the wavelength. This is a subtlety worth mentioning because it shows that the full picture is richer than any one explanation. Absorption by electron energy levels is the main reason walls block light. But scattering off of structural features, reflection from surfaces, diffraction around edges, all of these play supporting roles. Physics gives you a toolbox, not a single wrench. Let me come back to the radio wave. Your radio signal from the box in the living room is oscillating at about 2.4 billion times per second. That is the frequency, 2.4 gigahertz. Now, what energy does that correspond to? Tiny, incredibly tiny, We are talking about a photon energy of roughly 100,000th of an electron volt. Compare that to a visible light photon, which carries about 2 electron volts of energy. The radio photon has literally 100,000 times less energy than a visible light photon. That amount of energy is far too small to match any electron transition in any normal solid material. The electrons in your walls